Alright, in this video I'm going to talk about the derivative again, or the instantaneous rate of change, or the slope of the tangent line. But this time I'm going to talk about how we can do it if we want to find the derivative at any point, so just as an expression in terms of x. Or we could still do it as a specific point, but I don't have to be given a specific point. So for example, in this one, notice that I'm not giving you a specific value that I want the derivative at. It's not the f prime or derivative of 3 like we saw in the last video. I just want to find the derivative in terms of x. And if that's the case, then we can use this other limit expression, which says the limit as h approaches 0 of f of x plus h minus f of x all over h. And what this really is similarly the change in y over the change in x, but think about h as kind of the distance between those two x values, and it's going to 0, so it's becoming 1 point or an instant rather than an average between 2 points. So let's take a look at how we can use this expression for this function right here. We'd say the limit as h approaches 0 of f of x plus h just means to plug in x plus h to both of our inputs in our expression. So we'd say x plus h squared plus 2 times x plus h plus 1. I replaced this x and this x with x plus h. Minus, we want to subtract f of x, and I want to subtract the whole function, so I'm going to put parentheses around it, x squared plus 2x plus 1, all over h. Alright, great. So let's go ahead. We can't plug in 0 because we're going to get an indeterminate form. So let's go ahead and start simplifying the top to see if we can maybe cancel that common factor of h. So the limit as h approaches 0, well, when I expand this, I end up with x squared plus 2xh plus h squared. When I distribute the 2, I end up with plus 2x plus 2h plus 1. And when I distribute this negative, I end up with minus x squared minus 2x and a minus 1 all over h. Alright, let's look for some like terms on top. I see x squared here and a minus x squared here, so those are opposites. They're going to cancel. 2xh, no like terms for that, so I'm going to leave it. H squared, no like terms for that. I'm going to leave it. 2x, I see a minus 2x, so those will go ahead and cancel. 2h doesn't have a like term, but plus 1 and minus 1 should cancel. So everything I'm left with, each of these terms has an h in it, which is good because we're trying to cancel a common factor of h with the bottom so that we can get away from this indeterminate form. And as long as all of these have h's, I should be able to factor an h out front. So I'm going to pull an h out front. That'll leave behind 2x plus h plus 2 all over h. And now my common factor of h will cancel, and I'm left with the limit as h approaches 0 of 2x plus h plus 2. And to evaluate this limit, I can plug in 0, so I have 2x plus 0 plus 2, or just 2x plus 2. So f prime of x, or the derivative of f of x, is 2x plus 2. And remember, I wasn't given a specific point, so my answer should be an expression in terms of x. Now, if I wanted to find the derivative at 3 or the derivative at 5 or whatever number you would want, you could plug that number in here and find the actual numerical slope at that specific point on the function.